Hello everyone. One rainy afternoon I was looking through a few of my many unfinished projects and came across a little idea I started several years ago, where you play as a pilot flying around and delivering packages to people all over the globe. Taking a closer look, I found the controls were slightly unrefined, to put it politely, and though my geographical knowledge is quite terrible, I could hardly fail to notice the mysterious Sudan-shaped hole up here in Africa. I thought it might be fun to revisit this idea, but I've decided to start again from the beginning rather than try fixing up this buggy old project. So let's begin by making the Earth. I've borrowed some sphere generation code from this old tutorial series of mine on procedural planets. It's not terribly interesting, the main part is just this function for generating a flat plane mesh pointing in some specified direction. Then there's this bit, which uses that function to generate 6 faces pointing in these directions to create a nice little cube. And we can control the resolution of that. Finally, there's this tiny function, which takes each point and normalizes it, which just means dividing the vector by its own length, which causes all the points to be the same distance from the center, transforming our humble cube into a perfect sphere. At least in theory, but it seems that either maths is finally broken or I've made a typo. Here it is. This should be a plus. Alright, much better. Although, if we're in a nitpicky mood, we might be bothered by the fact that these points are a lot more clumped together at the corners of the faces than in the centers. Fortunately, some clever person has come up with this fancy equation, and I'll quickly plug that in instead. As you can see, that just spreads the points out a little more evenly, which is maybe not a huge deal, but it helps me sleep better at night. The next thing I did was download and stitch together this very beautiful height map of the world. And I was interested to learn that a lot of this data comes from an old space shuttle mission, and the basic idea is that radio waves are bounced off the surface of the Earth, and the height of the terrain calculated from how long it takes the waves to return. This has been combined with data from many other sources to fill in gaps and also to include a map of the ocean depths, measured in part by ships bouncing sound waves off the ocean floor. So now we just need to be able to convert any point on our sphere to a latitude and longitude, and then we'll be able to read the corresponding height value from the map. And being able to convert in the other direction as well is almost certainly going to be useful at some point, so I've been fiddling with sines and cosines and swapping numbers around until I finally ended up with these two functions. And just to test that they're definitely working properly, I used them to make this little animation of the height map wrapping itself up into a sphere, and then unfurling into a flat plane again. With that confirmed to be working, I've then projected the height map onto that nice sphere we made earlier, and using the height information, we can then push the vertices in or out to create this very vertically exaggerated little model of the Earth. I find it fascinating looking at the terrain that lies beneath the oceans, like this gigantic mountain range snaking through the middle of the Atlantic. As someone with a very rocky foundation in geology, I've been reading in amazement about how this is at the boundary of 2 oceanic plates, which are drifting apart at a blistering pace of several centimeters per year, and how the rift that forms between them gets filled by magma welling up from below, causing the underwater mountain to spread out over time. It's got me very excited about the prospect of doing a tectonic plate simulation sometime. I think that would be a lot of fun. It's also interesting to me how all these islands just look like one solid landmass. I'm kind of curious how deep the water actually is around here, and I guess we can find that out. I'll go into the world shader quickly, and it's currently just reading the height from the height map, which gives a value between 0 and 1, and it colors the terrain between black and white based on that. There's also some lighting stuff that I've left out here for clarity. But let's convert that height value to meters. So I know the lowest point in the map is about 11,000 meters below sea level, somewhere here in the Mariana Trench, and the highest point is around 8,000 meters up in the Himalayas. Mount Everest is almost 9,000 meters, but some of the extreme values have been lost since I've squashed the entire world into a measly 130 million pixels. Going back to the shader, I'll calculate the height in meters, and then if the current height is above sea level, we can output a different color for that pixel. So let's pick a color here. I guess green makes sense, and with the sea level set at 0 meters, we can see all these little islands dotted around. Then I'll just start lowering the sea level, and we can see the islands starting to join together, and get an idea from that how deep the water is. So here's what things would look like if the oceans happened to be about 80 meters shallower. I'm not quite sure what I actually want to work on at the moment, so I guess I'll just keep messing about until inspiration strikes. I eventually decided to make this simple little player controller so we can fly about and explore the world. When you're working with a spherical world though, it's important to test what happens at the poles, because that's where things tend to go a little pear-shaped. And sure enough, we can see the camera is starting to get a mind of its own, so that's going to need some work. After some fiddling around, I now have this bit of code for the player, and this here for simply following along with the camera. I've also been spending some time in Blender struggling to make this little aeroplane, which I'll bring into the game, and let's take it for a quick test flight around the Antarctic. I noticed there's a strange hole up here in the ice, which I guess must be where they stick the South Pole. Alternatively, it could be just another bug in my code, but I like the first theory better. Anyway, I hope you don't mind indulging my newfound enthusiasm for geology again, because I've just been learning about how that South American plate we saw earlier is colliding over here with something called the Nazca Plate, which is being forced downwards, resulting in this amazing trench all along Chile and Peru. That same collision is also responsible for compressing the South American plate all along its western edge, pushing up, of course, the Andes Mountains. Geology is very cool. Significantly less cool, unfortunately, is my GPU. So an important optimization is something called Frustum culling, where only the objects whose bounding boxes are actually within the viewable region of the camera have their mesh data sent to the GPU. But as you can see, because I made the sphere out of just 6 chunks, it's having to send a lot of data that's obviously not going to end up on the screen. So I've been making some small tweaks to the sphere generation code to allow each face of the underlying cube to be split into multiple subfaces. So now, if we run this again, you can see it's able to do a much better job of culling the parts of the planet that are out of view, and my GPU is already sounding a lot happier. Another rather obvious optimization is to simply reduce the number of vertices. For example, here's a chunk that I've reduced to about 60,000 vertices, but because of that, it's lacking a lot of detail. Now, I'm currently drawing this with a little test shader that just outputs the normal vector of the surface as a color. The normal vector tells us which way the surface is facing, and that information is mainly used to calculate how much light would bounce off that surface into the camera, which lets us apply some simple shading like so. Now, there's only one normal vector per vertex, so the detail of the shading is limited to the resolution of the mesh, but it doesn't have to be. What we can do is take our height map and write a little compute shader which runs this code here for every pixel in the texture. And all it's doing for each pixel is calculating the world positions of the 4 adjacent pixels, from which we can calculate the direction of the terrain going northwards and eastwards, and then the cross product of those tells us the normal vector of the surface at the current pixel. So after running that code, the alpha channel of the height map still holds the height of the terrain between 0 and 1 like before, but in the red, green and blue channels, we now have this normal information. To actually make use of that, let's go back to our shader, and we can read in the normal vector from the texture like this, and use that for the shading instead. So for comparison, here's the old per vertex normals, and here's our newly generated normal map. Then here's the old shading, And now with the new normals, you can see we get a lot more detail, essentially for free. The next thing I did was find a nice color map of the Earth, and these are actually available for each month, which I thought was quite interesting to see. I've taken one of these and used it to give the terrain a splash of color. What I'd like to figure out next is some way of displaying the countries, possibly with outlines or maybe some sort of highlighting of the one you're currently over. I'm not quite sure yet. So I've downloaded some country data. It's basically just a big list of points defining the outlines of all the countries, and I wrote a little script to load that in, which was a very straightforward task that I nonetheless managed to bungle in a number of creative ways. But here at last are the countries of the world. This dataset actually came in 3 different levels of detail. I'm using the medium one, so you can see if I zoom in here it is fairly detailed, but these small islands over here, for example, are defined by just a handful of points. The next thing I've gone and done is load in some cities from another dataset. I don't know how exhaustive this dataset is, but that's 7,324 cities plotted here, in case you are curious. I'm a bit confused why we have cities in the Antarctic though, that seems a bit fishy, so let me bring up the details here. This is apparently Vostok with a population of 25. I presume it's some kind of research outpost, but let me look that up quickly. So I've learnt it is indeed a Russian research station lying at the southern pole of cold, right by the southern pole of inaccessibility, which is not the most enticing address I've ever heard. I will also mention this Wikipedia article takes a very dramatic turn halfway down. Anyway, after that brief diversion, I have now mapped this data to a sphere using that function from earlier. So what I'd like to do now is take these debug lines and turn them into a texture so that they can be drawn onto the terrain in the game. So I've written up this rather inefficient compute shader to do that. Essentially, for each pixel in the texture, it loops through all of the countries and checks if the current pixel is inside the bounding box of that country, and if it is, it then loops through all the line segments in that country's outline, and keeps track of how close the pixel comes to the nearest line segment, which it measures using this function over here. And once it's done all of that, it calculates the strength of the line, and writes it to this country data texture. To test that, I've made the world shader simply draw the texture onto the terrain, which gives us this. I think it looks fairly decent, although in places where the lines go over steep terrain, it does look a bit iffy, so there's probably a better approach that could be taken, but sadly I don't know what that is. Anyway, I'd still like to highlight countries when the player is flying over them, and I have a slightly convoluted plan for doing that, which I hope is going to work. The first step that I've been working on here is to loop through all the countries like we did with the outline, but this time we're checking if the pixel is anywhere inside of the country polygon. And if it is, then the index of the country gets written to that pixel in the country data texture. The algorithm for checking if a point is inside a polygon is something I just found online, but here's what that code looks like in case you want to know. Back in our world shader, we can now read the country index of the fragment of terrain we're currently drawing from the green channel of the texture, and to visualize that, we can just divide it by the number of countries we have to give us a color between black and white. And here's how that looks. Okay, we're slowly getting somewhere. What I've done next is make yet another compute shader which has this buffer holding a time value for each country, which is when the player last visited that country. Then this code here runs every frame, and it calculates first of all where the player is on the country data texture, and then it reads from that the index of the country that the player is flying over, and finally it sets that country's last visited time to the current time. Let's make one more trip to our world shader, where we can now access that buffer of country visit times. We can then use that to figure out how long it's been since the player visited the country we're currently drawing, and that information can be used to highlight recently visited countries like so. I did say it was convoluted. I've been trying this out, and it does actually seem to be working, which is a very pleasant surprise. So with that test successful, I've been experimenting with some different ways of integrating it with the actual world shader. One idea I thought was interesting was drawing all the countries in grayscale except for the one you're currently flying over, which would be in colour. When flying over smaller countries though, this does often leave a lot of the screen grey, which can be a bit dull, so I might experiment with something more subtle, like just brightening the colours of the country you're flying over. I've also been working a little on how the oceans are drawn, so here I've clamped all the heights at sea level to get a nice flat surface. We can still get the depth information though, and use that to blend between a deep and shallow watercolour. The results of this do look a bit strange in places, but I think it's okay for now. Then I'll borrow this snippet of code from one of my previous projects to add a specular highlight where the sun reflects off the water. That does make the water look very smooth though, so I'll take these two wavy normal maps and scroll them across the surface using a technique called triplanar mapping, which is something I covered in my old procedural moons and planets video, in case you want to learn more about that. In any case, that allows us to easily break the light up as though it were bouncing off little waves on the water surface. I'd also like to add a sort of cartoonish foam effect where the water meets the land. To do this, we need to know how far away from the shore any point in the water is. So, starting with a mask of the world, I've written a little compute shader where each pixel looks at the pixels immediately above and below itself to try update its own distance from the land. At first, only the pixels right next to the land can be updated, but over many iterations we can fill in all the vertical distances. Then we do another pass which does the same thing but horizontally, and together that gives us this nice little distance field. I also computed the distances inside the land, which we don't need, but I just wanted to see what it looked like. Here is the compute shader I wrote for generating this. It's quite slow, which is partially my fault, but it's also just a fairly slow algorithm. This here is the GPU side of the code, and here is the CPU side of it. I have heard of a much faster technique called jump flooding, which I'd really like to investigate at some point. But for now, we can map this distance field onto our sphere, and then the idea is to take the sine of the distance plus the current time to make these little sine waves that radiate out from the land. With a bit more fiddling, we can add some noise and scale it down like so to get these tiny little cartoony foam lines, which I'm quite fond of. The oceans do feel very empty at the moment, so I've been spending some more time in Blender making this little boat model. I then used my old path tool to make some simple little loops for the boats to follow, and here one goes. Something that looks a bit strange though, well, apart from the boat being about 150 kilometers long, is that the boat's not disturbing the water at all. So I've tried writing a compute shader that draws circles at the front of the boat and then slowly diffuses them over time by repeatedly blurring the texture. For some reason, I expected this to look like a nice foamy wake, which it really did not. Having thought about it some more, I think simulating the wake of a boat could be an interesting and challenging project all by itself, so for now I'll just try do something super simple instead. I've been playing around with this built-in trail render effect, but I was struggling to get it to do exactly what I wanted, so I decided to write my own trail renderer, and now several hours later I am struggling to get that to do what I want instead. Great progress. It's currently behaving rather mysteriously. You can see the result at the moment is very weird, but if you leave it running for long enough, it suddenly has a change of heart and starts sort of behaving. I'm not sure what that's about, but I've kept working on it, and I've eventually got it doing more or less what I want, although I am pretty sure by now I could have just done this with the built-in version and saved a whole lot of time. Anyway, I found these nice foamy textures online, and used them to create this admittedly slightly strange looking little effect. But an entire afternoon has already disappeared trying to make these trails, and I think it does look better with them than without, so let's just call it a success and move on. I should really be thinking about adding some actual gameplay, but the trouble is just that I'm having too much fun creating the world, and I really want to make some little clouds next. So a little while ago I managed to get my old cloud shader working for spherical worlds, and I've been considering using that, but I think I actually want to try something different here. In my most recent video I learnt a bit about GPU instancing for efficiently drawing many copies of the same object. And I've been playing around with that some more today, trying to make cloud shapes out of lots of little spheres. After some more experimentation, I've come up with this little compute shader, which runs for every cloud particle we want to spawn. All it does is pick a bunch of random candidate points on the surface of a sphere and evaluate this fractal noise function at each of them. The point that has the highest noise value then becomes the spawn point for that particle, and this should result in the particles spawning in distinct clumps, hopefully at least vaguely resembling clouds. Over here is the supporting code for that, stuff like the fractal noise function, generating the random points, and so on. Then there's also this part of the compute shader for updating the clouds. What's going on in here is, first of all, if the particle is within some threshold distance from the player, it gets appended to this render buffer, which is a new trick I learned that we don't have to submit all the particles we have for rendering. Then, if the particle is really close to the player, I thought it'd be fun if it actually reacts to the collision and gets knocked out of the cloud. Alright, let's try it out. So this is not quite what I had in mind, but no need to despair yet, because it might just be a matter of finding the right parameters for that fractal noise function. Let's maybe try increasing the noise scale to something like 10 instead. And this is actually already looking a lot better. We have some distinct cloud shapes, and there are some lonely particles floating around by themselves, but that's okay. Let's also try flying through one of these clouds, and that feels pretty satisfying. It maybe looks a bit odd, but I like it. Now, I have an idea for maybe making these look a bit more cloud-like, which is simply to blur them. So I've made a separate camera which draws the clouds into their own special texture, where we can apply some processing just to them. Here is that texture, and I've dug up some old Gaussian blur code I wrote to make these nice and blurry. Something else I want to try is also rendering the particles' normals into this texture, and blurring those as well. So now we can have another shader whose sole purpose in life is to combine the output from the main camera with our cloud texture. And I've experimented over here with giving the cloud some simple shading using those blurred normals. Let's see what that looks like. Okay, I wasn't expecting that. It seems to be rendering the inverse of the clouds, so I must have got some numbers back to front somewhere. 1 second. Okay, I've fixed that little issue, so now we can try increasing the blur strength, and I'll adjust the number of blur iterations as well, maybe something like this. I think that looks interesting, but honestly I might actually have preferred how it was looking before the blur, although I do like the subtle shading we get from those blurred normals, so I actually have an option here to blur only the normals and leave the alpha channel of the texture alone, which holds the shape mask. The style is kind of growing on me, and I think if I can get some shadows working for the clouds, that would help tie them in better with the rest of the scene. With the way I'm rendering them though, I think I might need to handle the shadow calculations myself, which is something I've never actually done before. It's always just been magic happening in the background. So I've been experimenting a bit with shadow rendering. I have this little test scene here with a directional light and a camera. Here's what our camera sees, but the idea behind shadows is to actually draw the scene from the point of view of the light source. We can then do some matrix maths to transform that in a way that lets us see from our camera where the objects would be blocking the light. Now, you might be concerned about the shadows appearing upside down, but don't worry, I've quadruple checked my maths and it's definitely correct. In the end, I found the answer to this issue in an obscure forum post in a comment posted 2 years after the question had already been answered. Thank you for your service. Captain Science. With the correction made, here is how the transformation looks now. Pretty good. We can of course change the direction of the light source, and it's not without some issues still, but mostly working. And here it is with the clouds. I decided to blur the clouds in the shadow render, even though I ended up leaving the actual clouds unblurred, because that looked a bit softer and nicer. Now, I should mention there's a lot more than this to a proper shadow implementation, involving depth buffers and various ointments for shadow acne and other such issues. This is really just a quick hacky thing I tried to get working for the clouds alone. Now, with some clouds in the game, I couldn't resist quickly trying to integrate the atmosphere shader from one of my older videos. So I dropped that in, and it really didn't get along well with my cloud system. I can't even really tell you what's going on here, but I did manage to patch it up in the end. Here's what that looks like. As you can probably tell, I also changed the game camera a bit so that you can actually see the atmosphere, otherwise it would have been a little pointless. Okay, so the original idea was that you're a delivery pilot, so with the cloth simulation in mind from the last video, I thought about trying to simulate a little parachute for dropping the packages. But after some not so promising tests, I decided to just make a simple animation for the parachute instead. I have now put that into the game, so we can fly around and deliver packages to our heart's content. I've also switched back to the top-down view here, because this way it's a lot easier to see where the packages are actually going. So all that remains to be done, for now at least, is to tell the player where the deliveries need to be made, so that you're not just flying around aimlessly. So I've made this super simple UI, which just gives the player a random country and a random city within that country. Then when you deliver the package, you'll be evaluated on how far away from the city it lands, which is done using this tiny function. Let's try it out. So starting off, we can choose between Brazil, Lesotho and Togo, and I've decided to head to Lesotho since we're in the neighbourhood, and also it's a fairly small country, so even though I don't have a clue where the city of Maseru is, it's not really possible to be too far wrong at least. Let's make our next delivery to Madagascar. This time I've never even heard of the city, let alone know where it is, so I'm going to make a wild guess and say it's somewhere on the south coast. Nailed it. So, like most of the little games I've made, I think this was a lot more fun to create than it would be for anyone to actually play, which is fine, but I have been thinking about how the gameplay could potentially be spiced up a smidgen. One thought was having other aircraft you need to dodge, or possibly even pesky package pirates pursuing you through the skies. Could be interesting. I'd of course love to hear if any of you have thoughts on how this could be made more fun to play. Now, you probably noticed something a bit disconcerting happening with the lighting just there. I was struggling to make the game look good at night. Obviously, if it's just very dark, then that's really annoying to play. So for now, I've just made the sun kind of awkwardly follow you around, but if I do end up revisiting this project in the future, I'd love to add things like city lights at night, and maybe there could be giant lighthouses illuminating the oceans, or something silly like that. I suppose one could even just attach a giant spotlight to the aeroplane. Another thing I'd love to experiment with more is the clouds. The cloud formations obviously aren't terribly realistic or interesting, but perhaps one could spawn the particles and maybe even move them based on historical weather data. I think it would be really cool to see huge cyclones forming and so on. Maybe I should just do an entire project on weather simulations. That does sound very complicated, but maybe some kind of simplified toy version would be feasible and still pretty interesting. One nice side effect of this project for me has been getting more of an appreciation for geology and geography in general. Even something as simple as just knowing where different countries are in the world I used to be really bad at, but now slightly less bad. I still have a lot to learn though. Coming up in a second you'll see me trying to guess the location of Bogota, and I thought the one place you probably wouldn't build a city is way up in the mountains, so I chose a spot down here. But no, it's 2.5 kilometers up high in the Andes Mountains. Anyway, this has been a really long video, so if anyone is still out there listening to me rambling, thank you very much for watching. I hope you've enjoyed the video, and I'd love to hear, by the way, where in the world you're watching this from. Alright, that's all from me for now, so until next time, cheers.